Chapter 10 looks at motherboards. We've examined several individual components of our computer so far. Now it's time to bring them together with the motherboard. The motherboard is the main circuit board of a PC. Every device accessing the processor is either mounted on or connected to the motherboard, either directly or indirectly. Four characteristics define modern motherboards: layout, chipset, expansion slots, and components. These determine a number of things for any system, such as what size case, type of power supply, processor, expansion cards can be used, as well as the total functionality of the system. Motherboards come in different sizes, but over time there have been two basic styles or form factors. Early motherboards installed in systems from the earliest IBM PCs up through the earliest Pentiums are the AT motherboards. These are distinguished by the type of keyboard port and the power supply connection. AT motherboards have a 5-pin DIN or large keyboard port and a P8, P9 power supply connection. Current motherboards are the ATX form factor models. They often have 6-pin mini DIN or PS2 keyboard and mouse ports and a P1 power supply connection. These motherboards are found in systems from the Pentium 100 systems up through today's PCs. Each of these comes in different sizes, as well as some variations for desktop as opposed to tower cases. Another way that desktop cases were kept small was by the use of riser cards on the LPX and NLX motherboards. This was an expansion card with slots for other expansion cards to be installed into. The riser was perpendicular to the motherboard. The installed expansion cards were then parallel to the motherboard. ATX boards come in several sizes. The standard ATX, micro ATX, and flex ATX have different size specifications and onboard components at different price points. Also in the small-sized motherboard form factor are the ITX variants. Mini ITX boards are about 6.7 by 6.7 inches. Nano ITX are 4.7 by 4.7 inches, and the Pico ITX boards are the smallest at 3.8 by 2.8 inches. These are usually used for embedded systems and specialized devices. Because of their small size and low power draw, they use passive cooling methods. The component on motherboards that most determines what processor and what kind of RAM can be installed on that board is the group of chips collectively known as the chipset. The chipset handles some data and signal coordination on the motherboard. They are electronic interfaces through which the processor, RAM, and other devices can interact. These chips vary in feature, performance, and stability. Most modern chipsets consist of the two primary chips, often called the North Bridge and the South Bridge, as well as a Super I/O chip for legacy support. North bridges are usually centrally located, and South Bridge chips are located between expansion slots and the drive controllers. The Super I/O chip handles many of the devices not covered by the main chips. Slow input-out devices like a floppy drive controller, serial, and parallel ports are managed by this chip. Some Super I/Os also handled the infrared connection, along with keyboard functions and modems. The ROM BIOS provides the basic support for the chipset, but to get full functionality today, you would load drivers specific for your operating system in order to support all of the chipset's features. Motherboards come with a driver CD containing these drivers, as well as support programs and other extras. So if you're building a system, you want to make sure that you look for this information. Intel and AMD make chipsets, but NVIDIA also makes them. If a company doesn't use the terms North Bridge and South Bridge to define their chips, they may refer to the memory controller hub or system controller instead of North Bridge, and the I/O controller hub or peripheral bus controller for the South Bridge chip. Motherboards have a socket or a slot for mounting the processor. This will vary depending on the type and model of processor it will accommodate. Remember that sockets are for PGA and SPGA processors and their variants. Slots were for the various SEC and SEP cartridge processors, like the Pentium 2s and 3s, some of the Celerons, and the early AMD Athlons. Current Intel processors use a form of ZIF socket called a land grid array, or LGA. This is covered when the processor isn't installed in order to protect the contacts. The system clock crystal will be somewhere on the board. Your book has an example. ROM BIOS and CMOS chips are usually identifiable on motherboards with a label from the BIOS setup maker. So look for a label with Phoenix, AMI, or Award written on it. Also look near the BIOS or CMOS chip for the system battery. On recent motherboards, it will be a circular disc. Older systems may have used a 9-volt battery or some other battery attached to the case with a wire leading to a motherboard connection. Each board will have RAM slots for DIMMs or RIMs or possibly SIMs depending on the age of the board. A very old board may not have memory slots at all, but will have the RAM chips mounted directly on the motherboard. You may also find RAM cache chips on the board, depending on the generation of the board and processor used. Cache was common on 486, Classic Pentium, Pentium MMX, and Pentium Pro motherboards. After this, remember, cache was built into the processor and the processor package. Now again, however, you might see additional cache on the motherboards in order for the system to keep up with the processor. Expansion card slots may be of several types. An ATX motherboard may have ISA slots, PCI slots, an AGP slot, or PCI Express slots, or some combination of these. You'll generally find several sets of pins known as controllers. These are where the data cables from your various drives attach to the motherboard. PATA, or parallel ATA controllers, for IDE hard drives and ATAPI CD drives both look the same. That is, they have 40 pins. If your motherboard supports high-speed hard drives, that PATA controller will generally be designated as such by being a different color. The controller for the floppy drive, if one is in use, has 34 pins. These are usually labeled in very small print somewhere on the motherboard near the controller. Newer boards are now providing support for serial ATA devices. These SATA or SATA connectors are small ports with 7 wires, and there may be 2, 4, or more of these ports on the board. There will be a connection for the power supply cables. On today's ATX boards, this is the P1 connector, and there may be an auxiliary power connection for different processor and maybe for fans as well. On AT motherboards, the power connection was for the P8, P9 connectors. Motherboards come with a variety of ports mounted directly on the board. The most common are the PS2 mini-DIN keyboard and mouse ports, USB, and FireWire ports. Serial and parallel ports are being phased out but can still be found on many boards. Depending on the cost of the system, you may find an onboard video port or onboard sound ports. Most of these ports are on the back of the case, but increasingly manufacturers are putting USB and IEEE 1394 ports on the front of the case for easier access, along with some audio connectors as well. Some processor, power, or other system configurations are made possible by the use of jumpers or dip switches. Jumpers are sets of 2 or 3 small pins, either covered with a small plastic shunt or left uncovered. Don't confuse these with the pins for the attachment of wires for your case LED lights. Dip switches look like a miniature bank of light switches. Different combinations of either jumpers or dip switches enable changes in configurations from processor speed, system passwords, enabling or disabling of onboard ports, and more. Linking all of these things together are the fine lines or traces, which are the bus. There are several different types and speeds of buses in a system, but they all provide a way for data, control signals, addresses, and power to move from one place to another. Since each motherboard is made up of several layers of material, you can't see all of the trace lines just by looking at the top or the bottom of the board. By having many layers in this way, interference is minimized. Also, the design of today's motherboards allows for shorter traces, which gives us faster transmission of information and signals. Choosing a motherboard and case can be a challenging task, if only because the choice of motherboard determines so many of the other choices to be made when assembling a system. Some people first choose the processor they want to use, then find a motherboard to support it. Others find a motherboard that contains the features and components they want, and then choose those components that are supported by that board. Choice of board affects the case as well. Remember that today's motherboards come in a variety of sizes, as well as either ATX or ITX form factor. Your case will need to be appropriate to the board size and form factor. We'll talk a bit more about cases when we look at power. Installing a motherboard into a case is not much more difficult than installing another component onto the board. But here again, you must watch out for ESD and make sure you are properly grounded when handling and installing the board. So static precautions apply. Leave the board in its anti-static packaging until you are ready to install it. Put a removed working board into anti-static packaging for storage. Also, make sure your work environment is as static-free as possible. This means don't work on a carpeted floor. Choose vinyl, tile, or wood flooring to stand on. In fact, there is something to be said for using your kitchen counter as the place to do your computer assembly. Usually, there are no carpeted floors. Static is at a minimum. Before replacing a bad board with a good one of the same type, Make a note of the position of those little wires for the case speaker, the power switch, reset button, and hard drive light. This can save you much time later on. To remove an existing motherboard, find the screws that hold the board into the case and unscrew them. These screws go through standouts, which keep the board from touching the metal of the case and shorting out. If you are installing a new board that is different from the old one, the position of the standouts will probably need to change. Put in as many as you can, anywhere you can. You want to make sure that there are standouts under the RAM slots and under the processor socket and cooling mounts, so that when you install these items, the board doesn't flex so much that it grounds out on the case. Very few boards seem to fit perfectly in every case, so this can be a trial and error process. Now, it's a good idea to test things once your processor, RAM, and motherboard are installed into the case. A post-diagnostic card can help. Simply install this into a slot, hook up your power connections, turn the system on. But since most of us don't have one of these cards lying around, the next best thing is to install a video card or use onboard video connected to a monitor and maybe a keyboard, and then power up. Because no drives or operating system are present, if the system boots, it will stop when post is complete. One of the features the ATX power supply has made possible for ATX boards and systems is soft power. This is the feature that lets software turn the PC on and off. It also means that there is no power running through the motherboard whenever the system is on. It also means that there is power running through the motherboard whenever the system is plugged into the outlet or a surge suppressor or other device which is drawing power. Make sure the system I'm going to try that paragraph one more time. One of the features the ATX power supply has made possible for ATX boards and systems is soft power. This is the feature that lets software turn the PC on and off. It also means that there is power running through the motherboard whenever the system is plugged into the outlet, a surge suppressor, or other device which is drawing power. You can damage your equipment by working on a system which is plugged into a power strip that's turned on. So make sure the system and your power protection device are off when you're working inside the case, or unplug the power cord from the back of the case. Soft power is provided by the motherboard via tiny connectors and wires leading to the case power button and LED lights. These connectors are polarized. They must be installed in the proper direction in order to work, but no damage is done by putting them in backwards. You'll usually find the pins for these connectors on the edge of the board nearest the front of the case. If you're lucky, the connections will be labeled with very tiny cryptic descriptions. Having the motherboard documentation is very helpful here in getting the wires connected properly to the appropriate pins. Troubleshooting motherboard problems can be a challenging task. Problems fall into one of three categories, either catastrophic, component, or ethereal. The catastrophic problems are fairly straightforward. The system won't boot. It can happen on a new motherboard because of manufacturing defects or from static somewhere down the road. Component failure is when communication between a device and the motherboard breaks down, such as a hard drive controller going bad, or damage to a RAM slot. These are not very common, but they can be caused by electrical surges and static, or by being too rough when installing or removing something from the motherboard. Ethereal problems are like intermittent problems elsewhere in the system, and they show the very same symptoms: flaky behavior. They can be caused by faulty devices, bad drivers, buggy software, or power supply problems. The text lists some suggestions on how to troubleshoot and isolate these ethereal problems. If the cause of any problem is traced back to the motherboard, the safest choice is to replace it and maybe get something better in the process. This concludes the presentation on motherboards.